Hey man, I got you covered. Don't worry about it. KMV and VP. We'll make the same video about talking about this amplifier. The subject about the what I was talking about the bias adjustment. But today I found something really interesting that you might like this video. I was checking the Golosa amplifier circuit. It's basically the same one, the AX-14 audio amplifier class AB, of course. This is designed by Mr. Mile Slavoskovics. I don't know how to pronounce this. From DIY.com, a solid state, 100 watts, ultimate fidelity amplifier. So, well, I found out something really interesting. I was doing some bias adjustment according to the voltage that I have. Right now, I'm working this with just two pairs. What I do, I just turn off these two extra pairs. You can see I'm going to highlight the transistor that power transistor that I'm not using right now. So you can see Q16, Q17, and Q19 and 20, they are off. If I double click on the transistor, the semiconductor, right here where you see fault, I just open emitter, collector, and base, so that transistor is not in use, just to simulate the two pairs. So right now I do have the illustration of the PCB is this one right here. I think I gotta rotate it. So this is the illustration of the same circuit, but only with two pairs. And but I was checking the circuit yesterday to make sure everything is correct. I did not find any error on the layout. Everything is good to go. So right now I'm going to explain you something that is really interesting about the bias according to the. It was really interesting because the this resistor, the emitter resistor, it's this one right here, emitter, it's kind of difficult to find the 0.22 ohms. So I decided to change that to 0.47. While I was doing that, I noticed that the all change, the adjustment of the bias was totally different. One example, I'm going to do it right now here. This one here is 0.22 and the result is different. I'm going to activate the simulation. Let me see, I think I forgot to. There you go. I have DC for 50.1 milliamps on this emitter resistor, as you can see on the 0.22 ohm resistor. But if I place this ammeter on the other one where you see this 0.47, the current is different. It's 39.1 milliamps. So the thing is that depending on the emitter resistor that you are going to use, maybe the values of the adjustment of the trim pad for the bias adjustment is going to be different. So I'll find out that really interesting. Right now I'm reading the voltage drop into this R24 resistor. Let me see, I gotta move this away because it's kind of confusing here. There. So R24 is the bias, reading the voltage across this emitter resistor, power resistor. Is a 5-watt power resistor. So I find out that the adjustment is gonna be different after I check the current. So the current is different. So right now I'm going to change all the resistor to actually only this one here. So you will see. I think the 0.47 resistor is more easy to find on on eBay. What the hell is this?
No, the Yeti was there.
Yeah, I was looking something about the Jetty. That's interesting. Okay, 0.47 ohms, 5 watts. It's more common to find on eBay. Okay, as you can see, it's really common to find this resistor on eBay. Okay, 15 pieces for $5. They got a different. I would rather buy on the USA area. I hope nobody get in the USA area is better, I think. All right, we have these. Let me see how many. Okay, I think it's too expensive. Might be too expensive. It says from Hong Kong. No, I'd rather go to. Let me see. I don't think the Tide Electronic. They don't have those. Let me see. I'm gonna check anyway. Yeah, this website is really good. I purchased resistors here, and they are really good. Okay, 5 watt resistor. I don't think they have those. Let me see. I gotta check. No, they don't have it. No, this is a 1 ohm resistor. Let's check on Mouser. Mouser probably they have those. Mouser. I'm gonna check to make sure they have it. Of course they should have it. Okay. Passive components. I need resistors right here. Passive okay, resistors. There you go. Metal. No. Wire one resistor. There you go. And I need 5 watts. 5 watts. And 0.47. There you go. 0.47. All right, let's see. All right. Okay, we have. Okay, I think this is the. This one should be fine. This one here. Omite. Okay, it's 5 watts. 0.47 ohms. This one should be fine. It's a little expensive. 71 cents. Ceramic house axial terminal power. The TU series resistors are our most economical power resistor. They are recommended for commercial application where low cost is critical. Okay, they are available in small standard packs for standard values or bulk package for even lower cost. All right. So we have 5 watts. This is the measurements. So okay, we have 5 watts here. The measurements here. The length of the. Okay, we had 22 millimeters. All right, 22 millimeters. That's not bad. 9 by 10. So it's 22 millimeters long on length. Okay, 22 millimeters. Let me see what we got here. Gotta go make sure. 22 millimeters. We had 22. Oh yeah, perfect. It will fit perfectly. All right, now we're going back to the simulation. Now that we change, I'm going to change this emitter resistor to be 0.47 so we can check the bias. Make sure the bias is correct again. Right, let's see. I'm going to turn on the simulation to see. All right, we have. I think I gotta press it. All right, here, 41 milliamps. Let me change this size of the. All right. Oh, there you go. Now you can see that clearly. All right, we have peak to peak. It's changing a lot. Gotta wait. All right. RMS 41.8 milliamps. DC, okay, current is 41.8 milliamps. So that means that I have to adjust it. On the voltage on the meter, I had 19.669 millivolts. So I need to change it. I need to adjust it to get about 50 milliamps. Sorry, yeah, 50 milliamps. Sorry about that. I'm thinking about another thing. All right, I'm going to adjust the bias. Let me change this to make it larger. This is the bias trim pot. I'm going to adjust it. Okay, let me adjust it to get about 50 milliamps. So I need to know how many millivolts I have across that R24 emitter resistor. Going to continue adjusting. Okay, we got 30. Okay, just gotta wait. Okay, we got 56 milliamps, so gotta go back a little bit just to get about 50 milliamps, not to get much. 50.6 milliamps. Okay, let's go back a little bit just to get about 50 milliamps. All right, we got 53. All right, 52.8. Okay, I gotta wait. 25% on the trim pad. I got 51 point. Okay, we gotta wait. 51.4. Okay, go back a little bit. 50. All right, there you go. So, sorry about that. I'm coughing. Sorry about that. So, the voltage across R24 is 23.8 okay, 23.85 millivolts. So about 23 or 24 millivolts should get you about 50 milliamps. Let me see. If I change the emitter resistor to a lower value, you will see that all the adjustment is going to change. So right now, the result that we have with the emitter resistor as 0.47 ohms, we have 50.7 milliamps approximately. So I'm going to change this resistor to 0.22 to see if we have some sort of changes. All right, I'm going to turn on the simulation. All right, now that we changed that emitter resistor to 0.22, we had 62.1 milliamps. That means depending on your resistor that you're gonna choose, because you can actually choose 0.22, you can use 0.33, you can use 0.47, even I think even 0.68. Let's see if how it's gonna behave with 0.6. Okay, let's go change this. This is really interesting for me. Okay, now we change this for 0.68 ohms resistor. So let's see how much current we got. You can see all change. We have 44.4 milliamps, so we got less current passing through. So that means that you can use 0.47. 0.47. This is really interesting. All right, I change it back to 0.47. That means that you can use a 0.47 ohms. That's common. That's common for the emitter resistor, and you got adjusted to about 23 millivolts to get about 50 milliamps. So to reduce the crossover distortion on the output. Let's see how it's gonna behave the amplifier now that I changed this to a better current. Let's see. All right, let me turn on the speaker on, and they're going to connect the signal generator. Let's see how it's going to behave. 1 kilohertz sine wave. Orani. Okay, let me connect this. All right, there you go. So we have all connected. All right, this is I call it the wattimeter to measure the power in watts. Osco, and the total harmonic distortion window is this one here that I'm moving right now, and I'm going to activate the simulation to see how it's going to behave. It's supposed to be on AC, not DC. The output of the audio amplifier is measured in AC, not DC. All right, let's activate reverse. All right, let's see how it's going to behave. Okay, really nice, really nice. Okay, we have 7 nanowatts. That's weird. Why we have 7 nanowatts? Did I turn on the speaker? Oh, it's off. That's alright. I forgot to turn on the speaker. My bad. There you go. All right. Now we have 886 milliwatts output. The total amount of distortion is 0.000%. Wow, this is amazing. It reduced the distortion pretty good. I'm surprised. All right, now I'm going to increase the amplitude to 500 millivolts to see how many watts we can get. We have. All right, okay, I gotta change this to normal. We have 22 watts. Total amount of distortion is 0.001%. That's pretty good. I'm going to increase the amplitude to see how many watts we can get. The supply voltage is 65 volt symmetrical, DC symmetrical. It's not unregulated. It's not. It does not have a switch mode power supply circuit on it. It's just unregulated. Okay, I'm increasing the amplitude to see how much power we can get. Let's see. We got 47 watts. That's weird. We should get more. That's weird. I think I might I did a change here and I forgot to put it the same. Okay, is this one here? I think I forgot to change it. Yep, must be that. Okay, give me a second, guys. Give me a second. Let's change this. I gotta see the schematic just to make sure the original schematic. All right, it's not this one here. Yep, it's not this one. I got a good memory. I remember. All right, I got a good memory. All right, let me see. Golosa schematic. I need a schematic. Give me schematic, please. Give me schematic. I don't see it. Maybe it's on the desktop. Trabajos. Okay, all right, let's see. I need to find the original schematic. It has a different name. A Kelvin. There you go. I found it. Okay, so this resistor RA is the original value is 560. So I forgot to change it on the simulation. So this one here is supposed to be 560. That's I think it's some part of the bootstrap of the amplifier probably. All right, let's see how it's going to behave now that we have that resistor changed to see how many watts we can get. All right, let's see. There you go. Now we're talking. Okay, we had 15 watts. All right, let's increase the amplitude. Let's change. I'm going to 650 millivolts amplitude. Let me see. All right, there you go. 167 watts. Holy shit. Okay, the total amount of distortion is pretty good. We had 0.00. Pardon, sorry about that. I talked too fast. 0.007%. That's pretty good. 167 watts to 8 ohms low. And I have not finished increasing the amplitude. I'm going to increase the amplitude. Let's change the scale to 50 volts here, just to see. All right. Let me see. 700 millivolts. We have 193 watts to 8 ohms low. That's pretty good. Give me a second. Let me drink some water. I need to drink some water. All right, now we have 193 watts. That's pretty good. I'm going to increasing the amplitude. We have okay, clipping. There you go. We got clipping. Houston, we got clipping. All right, let's go back a little bit. No, still clipping. The bottom is clipped. Okay, there you go. So I will say that with 700 millivolts amplitude, We have, damn, we have 200 watts. My God, dear God, this is crazy. And total amount distortion is 0.027%. I think because we adjust the bias really good to 50 50 milliamps. I think that's the reason that it has less crossover distortion. Okay. I'm gonna do this is more designed to for 8 ohms speakers, but I will change this to 4 ohms load to see load. So let me change this to load. I'm going to load. This should be reading on capital letters. Load. There you go. Load. What the hell are you doing, man? Load. Oh, damn! I'm stupid. I changed something that it should not change. It's supposed to be here. Load. Load? Load. There you go, load. Perfect. Okay, let me see how many watts we can get to 4 ohms load. 4 ohms. Let me see. No, it's clipping. It is clipping, but we have 400 watts. Holy shit. So I gotta go back, lower the amplitude. Still clipping a little bit. Okay, still clip. No, now it's good. So I would say that this amplifier can give. Let me go back. It's a little. The distortion is too high. Okay, there you go. So I will say that this is about a 300 watts amplifier for 4 ohms low. So it's pretty good. So basically, this is the circuit that basically this one here. So the good thing about this design is that I already tested. Mr. 30 tested too. So what I did, I just make it a little larger and to install it in this way, so it will have the coil, because on the original circuit it does not have the coil. So I think I have some pictures of the circuit somewhere, I think. Okay, let me see. AX-14, I think I should have it somewhere. Horani. Okay. Sorry about that, guys. I didn't mean to do that. My throat, man, my throat. Every time I make videos, this happens to me. Hey, actually, it's this one here. It's this one here. Probably you're wondering why I have that tool there. I was cleaning the solder, because after I get the PCBs, it has a little layer of solder, so I had to remove it. So it does not show out the heat sink. So that's why I was doing that. So I cannot find the picture. I think I believe I have it somewhere, other place. Let me see. AX-14. Nope, I cannot find it. All I need. Oh, there you go. Sorry about that, guys. Okay, basically it's this one here. This is the one that Mr. 30 built. As you can see, he's using a different resistor. He's using a 0.68 ohm resistor. So probably his bias adjustment might be different from my bias adjustment. So as you can see that you can use a metal TO3 transistor on this. That's why I decided to made it that way. It looks nice. I like it. I like the way it looks. But it sounds pretty good too. A good sound. So now I have this version that I create the PDF files if you want to try it out. So what I'm gonna do after I complete this video, on the description down below, I will leave the link. So if you want to try it out, this design, so that you can etch it at home with all the instructions and stuff like that, so you can build it at home. I will say that this will be a nice project to do. I also have the 4-pair version. You want to try the 4-pair, so you can even have even more power into this design. As you can see, this is the 4-pair version. Oh my god, what the fuck. 4-pair versions. It's gonna look like this after you put it into the heatsink. Make sure the Q10 needs to be attached to the main heatsink. This is the part of the bias adjustment. The transistor is really important to have on this circuit. Well, that's it, man. That's it, guys. I'm going to stop this video. I think this might be really interesting. When I was checking the resistor options, so what I'm gonna do, I'm going to check the different adjustment with the different values with 0.22, and I should write it down so I don't forget. So I'm going to do that right now. So I'm going to check bias adjustment with okay, sorry about that, with 0.22 ohms, 0. I think it's 33 ohms too, and 0.47 ohms, 5 watt, of course, 5 watts resistors, and lastly probably 0.68. You actually you can use 0.27 68. Sorry about that. I'll write it down here so make sure I do not forget. Okay, I forgot to write it down on the ohms. There you go, so I don't forget. So I'm going to do this experiment and I'm going to write it down on the results on the schematic. I'm going to create a PDF file of the schematic so you can follow this schematic. So you want to try out this circuit. Alright guys, have a good day. I hope you like this video. Please subscribe to my channel, give it a like to this video, and share also this video. Might be helpful for guys that are studying electronics right now, so for the young generation. So this thing that I'm doing right now, it took me a while. It took me a while to figure out, about 5 years, and I'm still learning. Alright guys, have a good day.